Please, can you hear me?
Morning to you too, dear.
Good.
Yes.
We are going to have our first class on what do you call it? Um, our class. Sorry, I think this one will be the only class on geometry because it's not very long. Yeah. Sabelo, I will check your tape for you when I finish here. Ne?
Right. Thank you, dear.
Okay, sure. Um. So with this unit, we are going to look at trigonometric functions. And please, the key in this section is for you. You must try and understand what. If you just try and get the understanding, I should believe you can be able to answer any question. So now, the first thing that I would like us to look at is what do you call it? Um, you have to know that every angle. We know that when once we are talking about trigonometric function, we are talking about angle, and every angle has got an initial side where it starts, and it has got a terminal side where it ends. So that is the first thing that you must know about angles. And um, so there are different angles here. Now, if you can look at this angle, it started from here, the initial side. Then it went one revolution, and it came back here. That means that it has gone 360 degrees plus theta. So that means that here is theta. Have you seen? So this angle can be the same as 3C plus theta. Then here too, it has started, the initial point is here, then it has gone in the opposite direction. So we all know that when it goes in the clockwise direction, the angle is always negative. Then when it goes in the anti-clockwise direction, the angle is always positive. So here too, it has got an initial side. Here, beta is here, but if you can look at angle theta, it has gone one revolution. I'm sorry, it went in the opposite direction. So it went one revolution, 60 degrees, then it came back here. So once you see that it goes in the clockwise direction, it means that your theta is a negative angle. But you have to know that beta and theta, it has got the same, but the angles are going to be different because it went different revolutions. Is there any questions there? We are going to look at examples as we go. So we know that when it goes 180 degrees is half rotation, 90 degrees is 1/4 rotation, that not. But I think when we look at examples, you are going to get exactly what I'm trying to say. And also, simply put, angles can be measured in degrees. It can be measured in degrees, and it can be measured in radians. But at your level, we don't use the degrees a lot. We use the radians. But once in a while, we are going to see degrees. And the most important thing is that you should be able to know how to convert from degrees to radians and from radians to degrees. Now, when angle is in radians, you always find pi somewhere. Pi somewhere. But when it is in degrees, you always see a number. No pi number. So convert an angle to degrees. When you want to convert an angle to degrees, when it is in radians and you want to convert it to degrees, when you want to convert to degrees, convert to degrees, when you want to convert to degrees, you just is simple and straightforward. When it is in radians, you want to convert to degrees, multiply by 180 over. And when it is in, you want to convert to radians. When it is in degrees and you want to convert to radians. When it is in degrees and you want to convert to radians, you simply multiply by I divided by 180. It's as simple as that. Converting from degrees to radians and radians to degrees. Please, any questions there? How when we convert from degrees to radians and radians to degrees? Any questions there? Then our next thing that we are going to look at is, so you have 75 degrees. Degrees. If you want to convert to radians, simply multiply by pi over 180 by pi over 180. Then you find out that 5 go here 15 times. 5 is going to go here um how many times will 5 go here? 5 will go into 180. If I can guess correctly, 25 will go here, if I'm not mistaken. Is it 26 times? Is it 26 times? How many times will 5 go into 180? Or I think it's 26 times. 26 times. So you are going to have 15 pi over 36. But you have to know that 3 can go here 5 times, and 3 can go here 12 times. So you are going to have 5 over 12 pi. Any questions? Okay, the next one says that convert 5 radians. 5 radians simply means that 5 pi. 5 radians simply means that 5 pi. That is radians, 5 pi. 5 radians, pi is radians. So 5 radians simply means that 5 pi. So to come degrees, you simply multiply by 180 over pi. One eighty over pi. So pi can cancel this one, and you can multiply 5 times 180, and you have your degree angle in degrees. then you can have your angle in degrees. Now, um, as I told you, an angle has always got um, an initial side, a termination side. Once you have got an angle, once you have got any angle, you have to know that each angle has got a y component and an x component. The y component, as we know it as the opposite, then the component will always be the adjacent. Then I use SOHCAHTOA. We can find the sine, cos, sine, opposite of a hypotenuse. And here will obviously be the hypotenuse. Here will be the hypotenuse. So we are going to know that sine is opposite of a hypotenuse, cos is adjacent of a hypotenuse, and tan is opposite over adjacent. So we must also take of that. Is any questions? Please, any questions? Okay, no. Then let's go. Um, then you also have to know the cast. Um, remember that back in the high school, you were taught something we call the cast. That in the first quadrant, this is the first quadrant number one. Cos is positive, sine is positive, tan is positive. But when it comes to the second quadrant, it's only sine that is positive, cos and tan is negative. When you are in the third quadrant, it's only tan that is positive, cos and sine is negative. And when you are in the fourth quadrant, only cos is positive, and tan and sine is negative. Then another thing that you also have to note is that there is this property of trigonometric function. When you have a cos of a negative, a cos of any negative angle, it's always equal to the cos of the positive angle. But for sine and tan, if you have sine negative theta, it is the same as negative sine theta. Then if you have an negative theta, it's the same as negative and theta. Before I even start, you have to also remember that when you are working in radians, you have to make sure that your calculator up there is in rad. Have you seen? And when you are working in degrees on your calculator, you have to make sure that up there you are having degrees. And you have to also note that sine theta, the sine, cos, or tan of any angle is always between -1 and 1. If you have any answer between -1 and outside -1 and 1, you have to know that you have to check the sign you are using up there. Whether you have to check whether your calculator you are working in degrees or you are working in radians. Because if you say your calculator is in radians and you are working in degrees, you are going to get the wrong answer. And the vice versa is also true. If you are supposed to work in radians and your calculator is in degrees, you are going to have a wrong answer. Okay, so you have to note that. So this is what I was telling you about the cast. First quadrant, all is positive. Second quadrant, only sign is positive, the rest is negative. Third quadrant, only tan is positive, the rest is negative. Fourth quadrant, only cos is positive, the rest is negative. Okay, so now let's look at a question. Suppose that sin theta equals to 2 over 3, and theta is between pi over 2 and pi. Determine the values of other trigonometric functions. Good. So, when they are talking about other trigonometric functions, they are talking about tan and sine, and tan and cos. Tan, cos. Then you have to know that the reciprocal of cos is cos. Have you seen that? The reciprocal of cos is sec. Then the reciprocal of sine itself is cosec. So these are the angles that you are going to find. These are the angles that we are going to find. Now, the first step is that you must know the quadrant you are working in. You must know the quadrant you are working in. So if we can check, it says that between over 2 and pi. That means that you are working in the second quadrant. Where here is going to be theta. Then in that case, here will be your opposite, and this side will be your adjacent. And here it has told you that sine equals to 2 over 3. So here will be 2 opposite. Remember that sine is opposite over hypotenuse. Opposite over hypotenuse. Then hypotenuse will be 3. So now, get the adjacent. You must use Pythagoras theorem, which says that 3 squared equals to 2 squared plus a squared. So a squared can be equals to, let me just do it, it will be equals to 5. And a is going to be equals to square root plus or minus 5. Square root plus or minus 5. Let us remember that here your adjacent is on the negative side of the Cartesian plane. It means that it's going to be negative, not the positive. Negative square root of 5. Is any questions there? Is any questions? Is any questions? Okay, so now, so if you are asked to find cos theta, so that cos theta is adjacent over hypotenuse. So it will be the same as cos theta. It's adjacent over hypotenuse. So it will be adjacent will be negative square root of 5 over 3. Then sec. Sec is the reciprocal of cos. So it will be hypotenuse over adjacent. It will be hypotenuse over adjacent. So it will be negative 3 over square root of 5. Then tan theta is opposite over adjacent. So tan theta will be negative square root of 5 over 2. Then cot theta. Cot theta will be negative 2 over root 5. In that order. So please, any questions on this? You see that the cast is very important because the cast, you must always know the sign of angle, and obviously cosec will be 1 over sin theta. So it's going to be the reciprocal, to be 3 over 2, as we see. Please, any questions? Okay. So now let's look at the next question. It says that suppose that cos theta is 3. Cos theta is 3. And between pi and 3 pi over 2. If it's between pi and 3 pi over 2, it simply means that it's between 180 degrees and 270 degrees. So here, if you draw your axis here, you are going to see that you are going to have what do you call it? Your um, you are going to have um, how do I put it? You are going to have your adjacent and your opposite, and your angle is going to be here, and your angle is going to be here. So let us remember that cot theta cot is the reciprocal of tan, which is going to be adjacent over opposite. Let us remember that cos itself is opposite over adjacent. So if cot is the opposite of sorry, is the reciprocal of tan, it's going to be adjacent over opposite. Is any questions there? But let us remember that when you are in the third quadrant, the x component is negative. So even though equals to 3, it's the same as 3 over 1. But because we are in the negative, that means that here is going to be negative because we are in the negative side of the what do you call it? Cartesian plane. And here is going to be negative 1. So negative 3 divided by negative 1 will be equals to 3. That's why we are getting 3 there. Is any questions there? Please, any questions there?
No questions, sir.
Okay, good. Then we can have our we can use Pythagoras theorem and know that our hypotenuse squared is going to be negative is going to be, sorry, let me write it here. Hypotenuse squared is going to be negative 3 all squared plus negative 1 squared. So hypotenuse squared will be equals to 10. The hypotenuse will be equals to square root plus or minus 10. Let us remember that the hypotenuse is always a positive. So it's going to be the positive 1, which will be square root of 10. So once you know, you can find any angle. For instance, and when you look at here, sin theta is opposite over hypotenuse. So it will be negative 1, which is opposite over hypotenuse, root 10, negative 1 over root 10. Cosec theta is the opposite. If sin theta is the reciprocal, sorry. If sin theta is opposite over hypotenuse, cosec theta will be hypotenuse over opposite. It will be root 10 over negative 1. We are going to get negative 10. And cos theta is adjacent over hypotenuse. So we are going to have negative 3 over square root of 10. Negative 3 over root 10. And sec theta is the reciprocal of cos theta, which will be hypotenuse over adjacent. So we are going to have root 10 over negative in that order. So in that vein, you should be able to answer all these questions here. You should be able to answer all these questions here. So let's just try one of them. So let us try number number 3, most probably let us try number 3, most probably number 5 and number 7. Now, number 3, we have cos theta. Let us draw our axis like this. It says that cos theta is negative 1, 3. Now, it says that, let us see that here is 0, here is pi over 2, here is pi, here is 3 pi over 2, here is 2 pi. So now, the question is going to be, it says that we are talking about number 3. Number 3. Please, I want us to look at number 2. Number 2. I'm very sorry. Let us look at number 2. Now, it says that cos theta. It says that cos theta is equals to negative 1 over 3. And look at here. It says that the angle is between pi and 2 pi. Pi to 2 pi is from here to here. So the question is it going to be this quadrant or this quadrant? That is when you use the cast. Because here cos theta is negative. So if you look at the second and the fourth quadrant, you see that cos can only be negative in the third quadrant, but it cannot be negative in the fourth quadrant. That means that this your angle must be in the third quadrant and not the fourth quadrant. Is any questions there? Is any questions there? Okay, good. So that means that then you are going to have your opposite in your adjacent, and your angle theta will be here. Your angle theta will be here. Okay. So you are going to have that know that here is always negative. So we are going to negative one because we are negative domain, and hypotenuse is always positive. Then if you use Pythagoras theorem, you can see that when you find the opposite, you are going to have 9 minus 1, which will be square plus or minus square root of 8. But here, if you can look at the y, it's in the negative side of the Cartesian plane. So you're going to have square root negative square root of 8. Then you can use the trig ratios. Sine is opposite of hypotenuse, tan is opposite of adjacent, cosine is hypotenuse over opposite, sec is hypotenuse over adjacent, and cot is adjacent over opposite. Then we can find all the trig ratios. Is any questions there? Let me go on. Can we go on? Can we go on? Um, okay, let's go. Now, our next one. So, if you can look at this, the most important thing is for you to be able to draw your cast and know where your um. The most important thing is for you to be able to draw your cast, and you should be able to know um where your this thing is going to be, where um your angle is going to be. Once you know that, you can easily use your cast to find your you can easily use your trig ratio SOHCAHTOA to find your other angles. So let us focus on that. Now, if we look at number 2, it says that tan theta equals to 2. Now, if you look at number 5, it says that tan theta equals to 2. Then it has told you that it is in the first quadrant. So if tan theta is equals to 2, then it says that the first quadrant. So that means that tan theta will be equal to 2 over 1. Then we are going to have something like this. Tan theta equals to 2 over 1. And the question I've told you specifically that is in the first quadrant. So that means that when you draw your cast like this, and theta is opposite, so your angle is going to be here. And theta is opposite over adjacent. That means that here is going to be your 2, and here is going to be your 1. Then your adjacent will be square root, sorry, your hypotenuse will be square root of 3. Once you know that, you can find all your trig ratios. Then if we can look at number 6. Number 6 is like this. Number 6 like this. We have it says that cosec theta equals to -2. So here is -2 like this. We know that cosec is hypotenuse over adjacent. So if we have cosec theta, equals to -2, the same as -2 over 1. -2 over 1. Then we know that cosec is the same thing as hypotenuse over opposite. You see that? So when we draw our class, um, we are going to have this. Then we know that this side is the negative side. So that means that here is, our hypotenuse is going to be 2. Then our opposite is going to be -1. Then our adjacent is, because we are going to have plus or minus square root of 3. So your adjacent will be +3. Then we can use our trig ratio to find our cos, sine, our all trig ratio, knowing very well that cos is adjacent of our hypotenuse, sine is opposite of our hypotenuse, cot is tan is opposite of our adjacent, cot is adjacent of our opposite, and all lot not. We can find every angle. So number 7, we have if you look at number 7, we have sec theta. Sec theta is sec theta it says is equal to 4. So it's going to be 4 over 1. Then we know that sec is the reciprocal of cos. So if cos is adjacent over hypotenuse, sec will be hypotenuse over adjacent. Will be hypotenuse over adjacent. So we are going to have this. So we are going to have this. Yeah. So it's going to be in the 4th quadrant like this. Then so that means that our hypotenuse is going to be 4. Our adjacent already is positive, so here we are going to have 1. And we can have our hypotenuse to be square root negative. Well, we are going to have plus or minus square root of -15, but you must choose the negative because your opposite is in the negative side of the your it's in the negative side of the y-axis. Then you can find a negative. Then you can, once you have got your all your points and you know the quadrant you can find angle in, you can now find your sine, your cos, your tan, your cosine, and what. Is any questions? Is any questions?
No.
Okay. So that means that we can go on. We can go on. So that's that. So I should believe you also know these special angles. be accurate to know that tan 45 is equal to 1. Sine 45 is 1 over root 2 or root 2 over 2. Sine 45 will be 1 over root 2 over or root 2. And when you come here, you can see that sine 30 will be 1 over 2, cos 30 will be, sorry, sine 30 will be root 3 over 2. Sorry, sine 30 will be 1 over 2, cos 30 will be root 2 over 2. That's adjacent of hypotenuse. And 30 will be 1 over root 3 or root 3 over 3. In the same way, when you have 60, that will cos 60 is 1 over 2. Sine 60 is root 3 over 2. And 60 is opposite of adjacent, so it will be 1 over root 3 over or root 3 over. And tan 60 will be opposite, so root 3 over 1, which will, so it will be simply be root 3. So we must know this special angle. So now, the question is that when you are given, you are asked to evaluate angles like this. You always have to find what we call the reference angle. So if you find the reference angle always gives us a special angle. The reference angle will always give us a special angle so that you can find and can easily find the angle it is. So for instance, see that here, they are saying that cos pi over 6. They are saying that cos pi over 6. Cos pi over 6. Now cos pi over 6 is already a special angle. Cos pi over 6, when you convert to degrees, it's the same as to 180. When you convert to 180 over pi. 1 over pi. So pi over 6 will be the same as 30 degrees. Cos 30, you can easily see from the special angle that 30 will give us adjacent 1 over root 3 or root 3 over 3. So because cos 30 is already a special angle, even if you can draw the if we can find the reference angle, it will be like this. If you want to find a reference angle, cos pi over 6 will pi over 6 is in the first quadrant. So we have pi over 6 here. We have pi over 6 here. Pi over 6 here. So the reference angle is the angle subtracted by the closest x axis, which is here is 0. So the ref angle is going to be pi over 6 minus 0, which will give us the same pi over 6. And pi over 6, as we can see, is a special angle. So we can easily find any angle. We can easily focus or the sine easily. Any questions there, please? Now the same for cos pi over 4 and sine pi over 4. They are all special angles because cos pi over 4 is the same as 45 degrees. So they are all special angles. So if you reference angle, you still have pi, then you can always the same for pi over 3. They are all special angles. You can easily find them. So in this case, you see that I over 6 is the same as negative sine pi over 6. Then pi over 6 is already um, a special angle, so you can easily find sine pi. So by here, when they give you that was negative pi over 6. So you have to know that when you find the negative here, so you must put the negative in the consideration. But here, if you have cos negative pi over 4, cos always is always the positive. Only when it's negative, it's always positive. Cos pi over 4. And it's a special angle, so you can find the cos cosine of that. Angle. The same for number 3, number 4, number 5, and number 6. All that you have to know is that when it is cos, it is the positive. When it's sine, you must bring the negative out. When it is cos, it is positive. Is any questions there? Is any questions?
So, sir, are you saying that with number 3, when it's negative, when it's sign negative, it's negative, right? Answer would be
Yes,
negative.
you always bring the negative out. For instance, for any angle, if you have sine, when you have sine negative theta, it's a property. I've seen that. Is the same as negative, is the same as negative sine theta.
Okay.
But when you have, and the same way, if you have tan negative theta, tan negative theta is the same as negative tan theta.
And cos is positive.
Yeah, yes, but only the cos is positive. When you have
Mm.
cos negative theta, is the same as positive cos theta. Positive cos theta. Any questions there? No questions again. Okay, then let's go on. Let's go on. So we must know that we are going to do examples here with the reference angles, and we are going to understand these things better. Like these drawings, I'm going to explain it to you better when we are doing the reference angles. So let's maybe I don't think I'm not too sure if I explain this like this, you are going to understand it. But if um, um I think you can refer to this table and you can be able to pick up what I'm trying to say. Can be able to pick up what I'm trying to say. So let's look at let's look at this angle. So for instance, if I have 5 pi over 4, you know that my pass is like this. my class is like so. When I have my class, here will be zero, here will be pi over two, here will be pi, here will be three pi over two, then here will be two pi. Now, so here you are giving five. That is number one. You are giving five pi over four. Now, five pi over four. If you are not so sure where it is, just to quickly do a quick conversion. Now, convert it to you multiply by one over. You multiply by one over five. Then you quickly see that five pi over four is going to be the same as 205 degrees. If I'm not mistaken. 225 degrees is 225 degrees. That means that it's, um, it's going to be the third quadrant. So we are going to have 5 pi over 5 pi over 4. 5 pi over 4. Is any questions here? Please, any questions here before we go on? Please, any questions on why it's in the third quadrant? 5 pi over
No.
4. Okay, good. So we can go on. Okay, good. So to find the reference angle, the reference angle will simply be the ask of the reference angle. The reference angle will be this 5 pi over 4 minus the closest um, x-axis angle, which is pi. So the reference angle will be 5 pi over 4, 5 pi over 4 minus pi. It will be equal to pi over 4. It will be equal to pi over 4. Now let's look at this number 2. Number 2, we have this. Number 2, let us remember that there will be 0 pi over 2 pi 3 pi over 2 and 2 pi. Now, let us remember that um, let us remember that if our angle is negative, we go in the in the clockwise direction. So pi over 3 is going to be pi over 3 is going to be this side. From here to here, pi over 3 is 60 degrees. So it's going to be here. Let's see. So here we are going to have pi over 3. Pi over 3. Then here is theta. So um process is still 0. So our ref angle will be, let us remember that the sign only gives us that shows the direction. The sign doesn't mean anything. The sign just shows us which direction are we. Are we going in the clockwise direction? Are we going in the anti-clockwise direction? This is the only thing that the sign does. When I say the sign, I mean a positive or a negative sign. So the reference angle is going to be I3 minus 0, which will be the same as I. And let's look at the next one. Our next one, we have 3 pi over 3, 3 pi over 4, 3 pi over 4. Now, 3 pi over 4, obviously, it will go in the anti-clockwise direction. But the key thing is that we must know which quadrant will this in this angle be. Now, 3 pi over 4, if you are not used to, just multiply by, convert to degree, multiply by 180 over pi. You quickly see that 3 pi over 4 is going to be in the second quadrant. So 3 pi over 4 is going to be here. Do you all agree with that? Do you all agree 3 pi over 4 will be in the second quadrant? Where here will be your theta. So here will be 3 pi over 4. Your closest x is pi. But let's remember that this time, this pi is bigger than this 3 pi over 4. So your ref angle, your ref angle is going to be pi minus 3 pi minus 3 pi over 4, which will give us pi over 4. Which will give us pi over 4. Okay, let's go next one. Let me draw my task again. We have 0 pi over 2 pi 3 pi over 2 2 pi. So 7 pi over 4. If you are not sure which quadrant, simply multiply by 180 over 5 degrees. And you notice that 7 pi over 4 is going to be Um, let me see. It's going to be in the fourth quadrant. Am I correct? It's going to be in the fourth quadrant. I think I'm correct. It's going to be here. So this angle is 7 I over 4. And because we have almost gone round of revolution, now your closest x will not be 0, it will be 2 pi. Have you seen that? So that means that your ref angle, your ref angle is going to be 2 pi minus 7 pi over 4, which will give us I over 4. Is there any questions? Any questions? Okay. Now, um, our next one, let's just clean and have it there. For next one, we have the we have 0 pi over 2 pi 3 pi over 2 2 pi. So here you have to see that we are not straight of all it's negative 5 pi over 7. Then you put in the clockwise direction. So if you are not sure the value of the angle, as I always say, multiply by 1. Then you will see that the straight of this angle is straight of this angle is um, 150 degrees. So that means that when you turn from here to here is 90. So that means that you are going to go in opposite direction. So 150 degrees is going to be here. So that this angle here is going to be equal to 5 pi over 4. So if you want to find the rest and the process of x pi, so you are going to have rest angle. Our rest angle is going to be equal to pi minus 5 pi over 6, which will be equal to pi over 6. Is any questions there? Okay, then we can go on. So you notice that anytime that you find a reference angle and you are always going to special amount. You are always going to so for instance, look at five five plus one, five negative five. Okay, please can you hear me now? Please can you confirm whether you can hear me or not? Okay, thank you very much. So we have negative 4 pi over um let me see. It's negative 4 pi over 3. So we have to know that once it's negative, we are going to move in the clockwise direction. Once it's negative, we are going to move the in the clockwise direction. So we will draw our axis like this. You know that um, here is 0, here is pi over 2, here is pi, here is 3 pi over 2, and here is 2 pi. So we have negative 4 pi over 3. If you are not sure of where the angle is, multiply by 180 pi. Multiply by 180 over pi. Then, and when you multiply by 180 pi, you will find out that your angle is going to be 240 degrees. So 240 is 90. That will be 90, 180. Then here will be 260 because we are going in the clockwise direction. So 240 degrees will be in the second quadrant. Because we are in the opposite direction or the clockwise direction. So here will be 4 pi 4 pi over 3. So here the closest x-axis is pi. So your reference angle will be 4 pi over 3 minus pi, which will be pi over 3, which will be pi over 3. So that means that 4 pi over 3 is negative 4 pi over 3, the same as pi over 3. So you simply find cos pi over 3. Now cos pi over 3 is the same as cos 60. So cos pi over 3 is a special angle which you can easily see the answer be, if I can guess correctly, to be half. Then you have your answer. I forgot something. Please let us remember that um, your angle was in the second quadrant. Have you seen that? And here to the cast applies. Have you seen that? The cast applies. The cast applies. So you have to know that any angle that you find in this one is in the second quadrant. In the second quadrant, cos is what? A negative. In the second quadrant, cos is a negative. So whatever angle you have there, cos pi over 3, you must have a negative answer. So it's going to be equals to negative half. Is any questions there? Is any questions there? Okay, good. Then let's go on. Now, um, this one and this one too is simple. So let us try and pi over 7. Let us try and pi over 7 and 7 pi over 7. Oh, sorry, and 7 pi over 6. Sorry. So in the same way, if we draw our cast, then here will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Boom. So now, we have to see that um, 7 pi over 6, as I always say, if you are not sure, convert to degrees. Multiply by 180 over pi. 180 over pi. And is if you do that, it's going to give you 210. 210, that means here is 91. That means that it's going to be in the third quadrant because you are going in the anti-clockwise direction. So 7 pi will be um 7 pi over 6. So we are finding tan pi over 6. And in the third quadrant, tan is positive. So you have to keep the positive. But you must find the ref angle. The ref angle we know is going to be 7 pi over 6. 7 pi over 6 minus pi, which will give you pi over 6. It will give us pi over 6. And then you can easily see that 7 pi over 6 is the same as pi over 6. And it's a special angle, so you can always calculate using the special triangle. And the third quadrant, tan is positive, so you don't need to change the sign. There's no need to change the sign. So in the same way, if the next one, if we have this, the next one is like this. and we have this here we have 0 pi over 2 pi 3 pi over 2 and 2 pi. Then you have to note that 7 pi over 4, we are now looking at 7 pi over 4, 7 pi over 4, 7 over 4. Now, if you can, if you are not sure, simply multiply by 180 over 5. 180 over 5. Then you will notice that 7 pi over 4 is going to be in the is going to um, be in the fourth quadrant. It's going to be in the fourth, which is here. Now in the fourth quadrant, cos is positive, so there is no need to change the sign. You only have to find your reference angle. Your reference angle, you know, is going to be 2 pi minus 7 pi over 4, which I think will give cos to pi over 4, which is a special angle. And you know that is the same as cos pi over 4. So you don't need to change the sign. You simply find cos pi over 4. Yeah. So now let's look at the last one. Our last one, we have 0 pi over 2 pi 3 pi over 2 2 pi. Now, if you are not sure, as I always say, we multiply by 180 over 5. And you are going to see that um, we are on page 130 unit 6. We are looking at the examples there, 130 unit 6. So please, you see that it is 210. I'm sorry. When you find when you multiply by 180 over 5, you find out that your angle is going to be 150. So you're going to have 90 180, which is going to be here. is going to be, so here is going to be 5 pi over 6. So your ref angle is going to be pi minus 5 pi over 6. Then we'll get pi over 6. That's our reference angle. But don't let us forget that we are finding cosec. Cosec is the same as 1 over sine. Have you seen that? And sine is the same as 1 over sine pi over 6. But in the third quadrant, sine is negative. The third quadrant, sine is negative. Can you see that? So if we find our answer, which I should believe is going to be half, we are going to get negative half, because in the third quadrant, sine is negative. Is any questions?
So can you please do activity 6.5 and 6.6?
6.5, let me see. Let me 6.5. 6.4. Okay, let's see. Okay, it says that give the coordinates x and y in the unit circle of p theta for the given value of theta. Please, what do you understand by a unit circle? Um, what do you understand when we say a unit circle? Who can give me a meaning when we say a unit circle? Who can help me here when we say a unit circle? Who can help us here? Okay, simply it's a circle that has got a radius of 1. Have you seen that? So it means that when you draw the circle like this, when you draw a circle like this, everywhere has got a radius of 1. 1, like the radius of the. Okay, good. It has got a radius of 1. So let's look at the first one. If um, the circle has got a radius 1, let me the first one. The first one, I'll have something like this. It says that if it has got a radius of 4, then that means that the point here will be 1 and 0. The point here will be 0 and 1. The point here will be -1 and 0. And the point here will be 0 and 1. So the circle will be like this. I cannot draw it to scale. See? So now, let us know that when they say that is equal to pi over 2 is 0 and 1. Any questions on the first one? Any questions on the first one?
No.
Okay, now the second one, it says 3 pi over 4. 3 pi over 2 is going to be here. So your coordinates, x and y coordinates, is going to be this one. This is going to be 0 and -1. Number 2, over the one is clear. So what number 2? 3 pi over 2 is the same as 270 degrees. Three pi over 2 is the same as 270 degrees. So is there any question with the second one? The answer for the second one. Is there any question for the answer for the second one? Okay, good. Now let's go to the third one. Now the third one, we have 5 pi over 4. So we need to find the reference angle. So 5 pi over 4, let's multiply by 180 over pi. You find out that we are going to get it's going to be the third one like this. It's going to be here. But this time, oh my god, I'm doing this thing. Let me draw it again. So it's going to be here. Um, Let us remember that our circle is a unit. Then here is 0, pi over 2, I, 3 pi over 2, and 2 pi. So if you can check, now that means that our angle is going to be here. It's going to be here. We are going to have here to be, what do you call it? 5 pi over 4. Is any questions there? Please, any questions there?
With number 3, then what is our coordinates? Is it also going to, does it also
Yes,
change
we are
or?
going. Yes, I'm getting there. So do you understand? Do you get? So do you understand if I say our reference angle is pi over 4?
Yes, I do.
And do you also understand if I say the radius is 1, the hypotenuse is 1? So it's a unit circle. Have you
Yes.
seen that? Good. So we can use go to find the the x component. Have you seen that? We can use cos cos pi cos pi over 4 equals to adjacent, which is the x over 1. You can find the x component. Have you seen that? Then if you want to find the y component, you can use sine pi over 4 equals to opposite over 1. Then you can find the y component. Can you see that?
Yeah.
Yeah, so that's how you can find the coordinates of x and y.
And you use it using like reference angle.
Yes, you must use the reference angle.
So for example, our reference angle here is 45, right?
Does it make sense to you?
Can you please explain it again?
Okay. Let's start all of it. Um, like this. You understand that the circle is a unit circle.
Yes.
Listen, it's a unit circle like this. So you find out that the number 1 and the number 2, it was straightforward. Why was it straightforward? Because number 1 was 90 degrees. So
Yeah.
the radius is 1. So it is here. So we can see that it's 0 and 1. Have you seen that? And number
Yes.
2, it was 270. It will be here. It will be 0 and -1. That's what now.
Yeah.
Good. But number 3 was here. Number 3 was here like this.
Yes.
And our our angle is going to be here. Our angle is
Yeah.
going to be here. So when you find a reference angle, you are going to get 5 pi over 4 minus pi, which will give us pi over 4.
Mm.
Have you seen that?
Yes.
You know that it's a unit circle, so um the radius is 1. Have you seen that? That means that from here to here we are going to have 1. You see that? You know
Mm-hmm.
that your reference angle is pi over 4. Have you see that?
Mm-hmm.
So you know the hypotenuse and you know your reference. So you can easily use that to find your x component and your y component. Okay. Let me see it now. Like if I want to find, so you see, my point is here. I'm looking for this point. I can't say that. I'm looking for this
Yeah.
point. So I'm going to find. I must find the x. The x will be here, and the y will be from here to here. You see, so the x will be from here to here, the y will be from here to here, which will not be exactly one. I don't say that because it's on a circle. I don't say
Yes.
that. So I know that sine theta, sine is opposite of hypotenuse. So it's going to be sine. I know the angle is pi over 4. Pi over 4. Then sine is opposite. We don't know the opposite. So the opposite will be your y. I don't say that. Then
Yes.
hypotenuse, I know it will be the unit with the radius, which is what? 1. You
One.
can easily find the opposite, the y component. Or maybe if I make it y, you will understand why. The case here is y, and here is x. Let's see that. And if I
Yes.
want to find the x, I will say cos pi over 4 will be equals to x over 1. And I
Mm-hmm.
can easily find my x component. So my x, my y will be the point here. Does it
Um,
make, does it make sense?
yes.
It makes sense.
Yes. So meaning that is our answer going to be, if you're using for solving for x, it would be what is this?
Don't let's forget that, please, before I even continue, do not forget that sine in the third quadrant is negative. Have you seen that? And cos in the third quadrant is also negative. Have you seen that? Look, can you tell me the coordinates of that point? Yeah. Can you, can you tell me the points there to understand it? Then you will be able to tell me the coordinates there.
The coordinates.
Yeah.
Is it going to be square root 2 over 2 and square root 2 over 2? Negative. Wait, the other one
Remember
is
that sine is negative in the third quadrant, and cos is also negative in the second quadrant. In the third quadrant.
okay, so it's going to be negative square root 2 over 2
Good, good, good.
and
Negative square
square
root
root
of 2.
2 over
See,
2.
it even makes sense here. Have you seen that? You go negative square root to a negative square root. Now, it's the same for the last one. The
Okay.
last one, um, you first have to draw your cast. You have to draw your cast like this. Where here is 0, here is pi over 2, here is pi, here is 3 pi over 2, and here is 2 pi. Then we will have to see that negative, I'm going to go in the anti-clock in the clockwise direction because it's negative. So let
Yeah.
us find what angle it is. Now up, but we multiply by 180 over pi. We multiply by 180 over pi. Then once you do that, you are going to find out that you are having 240 degrees. So you are going to go 90, 180, 270. So that means that your angle is going to be here.
Yes.
It's going to be here. So here is going to be 5 pi over 4. 5
Yes.
times Then you have to know that it's a unit circle like this. It's a unit circle. So here is your theta. See, so if you subtract 5 pi over 4 minus pi, your reference angle will be pi over 4.
Yes.
And don't let us forget that in the third quadrant, sorry, in the second quadrant, sine is positive, but cos is negative, and tan is negative. I will see that. So
Yeah.
if you want to find it, so let us remember that if you are looking for this side, you are looking for this side, here will now be our x, and here will be our y. See that? So to find
Yes.
our x, it will be sine.
So isn't our reference angle 60?
Oh, sorry, I'm using that wrong one. It's 4. Oh, sorry, it's 4 pi over 3. Sorry. I was looking at the third one. So 4 pi over 3. Sorry. So our reference angle is going to be 60. It's going to be time. It's going to be pi over 3. I'm so sorry.
Okay.
Pi over 3. So we are going to have pi over 3. We are going to have opposite, which is the y that we don't know. For hypotenuse, the radius is 1. It's going to be 1. The
Mm-hmm.
sign is positive here, so you keep the positive. Then if we want to find our x, we are going to have cos pi over 3. But um, what is the coordinate for x and y or number 3? Tabello, it was negative root 2 over 2 and negative root 2 over 2. So it's going to be pi over cos pi over 3 equals to x over 1. Don't let us forget that on the second quadrant, cos is negative. Obviously that.
Yes.
Okay, good. So can you give me the coordinates for number 4?
It's square root 3 over 2 and no, sorry. For x, it's negative 1 over 2. And then
Mhm.
for y, it's square root 3 over 2.
Okay, good.
Okay.
So that's how we find the coordinates.
Okay.
Okay.
Thank
How
you.
many questions again? Mhm. Okay, then let's go to number activity 6,6. Now
Yes.
um, it says that if p of theta has coordinates negative 1 over root 3, find the following coordinates. What is happening here? Let me see something. I want to check something, please. Okay. I want to see something. Oh, we have got one last one here. That is 7 pi over. Okay, I should believe you go and do the last one yourself. Okay. Because
Yeah.
we are running out of time. I do the last one yourself. So I think we should do this one. No, you can do it. Remember, we are
Yes.
going to go in the opposite direction. So now, here it says that we have P of theta. So let us draw our angle. Then it says that theta. So if here is theta, you see the coordinate of theta, which we don't know, is negative 1 and root 3. It's coordinate of it's negative 1 and root 3. So it's going to be something like this. We can have negative 1, comma, 3. Of theta is negative 1 over 3. That means that in effect, in effect, what we are trying to say is um, yeah, when you have your y-axis like this, here is negative 1 and here is root 3. Then it says that p of I minus theta, p of I minus theta, what direction is it going to go? So, like if here is theta, if here is theta, let me correct. If there is theta, so p of pi minus theta, what direction is it going to go? What direction is it going to go? Look at us. Who can tell us? Who can tell us? Okay. So p of pi minus theta, if you are having p of pi minus theta, it will be the same as um, you having this. Um, let me write it correctly. It's the same as you having p. Um, let me take minus out. It's the same as p of theta minus pi. P of theta minus pi. So if you rotate it 180 degrees, this angle, this point is negative 1 and root 3 is going to come here. You see that? And here, you see that here will be negative, and here too is going to be negative. But there's a negative outside here. So it will safely be 1 and 3. Does it make sense to you? Does it make sense to you?
Why isn't it negative, what is this? Because you have here minus 1 and the square root of 3. So here, why doesn't it change to be the negative square root of 3?
Um, See that we are here. We are if you are here, let's look at it again. When you are here, you have sorry, it is 1 and negative square root of 3. Let me see that. See that here, your x is positive, your y is negative. Let me see that.
Okay. Yes.
That at that point, your x is negative, your y is what?
Positive.
Is positive. See that. But
Yes.
then we have brought a negative out. Let me see that. You see, you see that here we brought there is a negative out. There is a negative, what do you call it? It is equals to negative theta theta minus 5. Here we're having 1 comma negative um, 3. So once we bring um, our, negative out, we put negative 3. So it's going to be negative 1, and we will still get the same negative 1 because of the negative.
Okay.
Does it make sense to you? Any questions there? Is any questions there?
Could you start again, sir?
Must start again.
Yes.
Okay, good. The question is saying that um, we are having a theta coordinate. We are having this coordinate. Um, okay, no. Before we even do this, let's go back. Let me check something. Check something. Okay, let's go. Let's go back. Can't find what I'm looking for. Okay, good. It says that you have got a coordinate, which is p theta, which is p theta. Then this p theta is like this. Has got a coordinate negative 1 and root 3. So if the x is negative and the y is positive, then the negative 1 over root 3 is going to be Then here is going to be -1, and here is going to be √3. And here is this is P theta. Is that one understood?
Yes.
Okay, good. Then um minutes. Minute, please. I want to check something. I'm coming. Mm, okay, now let's go on. So we're having -1 and √3. Then now it says that we must find P of I minus theta. Now, for us to be able to measure this angle very well, we must try and interchange this so that we can see the direction properly. Because remember that here is I is 180. So I'm going to bring a negative out. Then I'll write it like this. Theta minus pi. Does this make sense?
Yes.
So now here is -1 over 3 √3, sorry. Now if you subtract 180 from theta is here, then and you take out 180, it will still come back here, this point. It will still come back to this point. You see that? It will be in actual sense, when it is here, it is going to be 1 and negative 1 and negative √3. Sorry. 1 and negative √3. Can we see that? Let me see that. Uh-huh. Because here will be positive 1, and here will be negative. Here will be the positive side, here will be a negative side.
Oh, okay, we understand.
Have you seen that? Because it has gone 180 degrees. You see that? But because of this, how do you call it? Because of this negative, it will reflect back where it was already. You see that? So the answer will still be -1 and √3. The answer will still be negative for this one. The answer will still be -1 and √3. Does it make sense to you?
Yes.
Okay. Now, if we look at the second one, it's like this. We still have this problem. Um, here, and we have been told that star is -1 and √3. So if as theta, that means that going to become 180, which is going to be here. When it is here, it will simply be 1 and -3. 1 and -3. So number 3, sorry, number 2 is 1 and -3. Any questions there?
So can you repeat number 2?
Number 2, theta plus I is going to be here with theta. If I add 180, it's going to come 4th quadrant. Obviously,
Yes.
in 4 quadrants, x is positive, y is negative. Does it make sense to you? Does it make sense? Okay, let's start again. Let's start again. I don't think you are following. You understand this coordinate. Eh? This coordinate, you understand this coordinate. This coordinate is x and y. So here is negative and √3. Let me see that. Okay, no, please, the time is up. Ne? So let us do this thing tomorrow. Exactly.
Yes.
Tomorrow is going to be a class the same time from 10 to 12. So we are going to start from here. We are going to start from here. That's fine with you.
Yes.
Okay, good. Because the time is up and I don't think you are following me. So let us tomorrow. I'm going to find another way to explain this, way to understand. That's it.
Yes.
Okay, good. So let us bring that to a close now. So tomorrow we are going to start with activity 6. Thank you very much.
Sir,
Hello.
do we can we schedule another session or
Yes, I'm scheduling another session for tomorrow
at what time?
at 10 o'clock.
Okay, no problem then.
Yes.
Can you please
So
send the link again?
for the second for tomorrow's class.
Yes, please.
Okay, yes. I'll send it. Give me, let's say, 10 minutes. You are going to have it.
Okay, no problem. On email, via email, right?
Yes, via email.
Okay, thank you.
You're welcome.
Bye.
And then we have it. That's it.